And thanks. I'll do this in English today to a little nicer to people that are more comfortable with that language, and my text is in English as well. So it's like Jakob explained. I've been doing some courses, mostly Java related, with Lund&Bendsen, and I kept getting these questions like, how do you do the live coding on your slides, and that it all sort of integrates. And I figured it's about time to say a little bit about how these things plug together. And so you might have figured out, it revolves around a program called Emacs, but there's a lot of ideas that go into it. Many of them not Emacs related at all. So I hope to give you a little bit of a introduction into the Emacs itself, like how I use that, and then the ideas and how I apply those to do things like live coding, but also write API documentation, write technical user guides for assignments that I'm on. Basically anything that involves both text and code snippets, or anything that is of a structural nature combined together, and trying to have the most comfortable way of working with that. If you at any point have any questions, just raise your hand and I'll try to address them. So the first thing I think we have to look a little bit at is computer programs in general, which I like to divide into two categories. Text editors is one of them. There's these programs that say, hey, we know how the world works. You have to change your way to match what we want. We give you these shortcuts. We give you these themes. This is how our view of the world is. Take it or leave it. A certain fruity company comes to mind. Then there's software that sort of works the other way around, which is made from principles to be allowed to be changed to match what a particular person would like that to behave. Like, it's up to you to decide how do I want these things to look, what colors do I want to use, how do I want to use the keyboard, how do I want to use the mouse, do I want to use either of these at all? And not just that, make it as easy as possible to extend it towards ideas that maybe the original authors have not thought of. Emacs is very much an example of the second category, as you may have guessed, and we'll see how that reflects in some real-world usage. And there's the other thing that's often connected with Emacs, which is the free software discussion. So free software, where the word free stands for freedom, as in the software is made to be free, means that you want to allow users to do whatever they would like with the software, but also continue to do so perpetually. And that's a big advantage for computer programs, because when you take the time to learn and invest time in that, you wouldn't want a couple of years later some company to decide, well, we're not making enough money and we're going to do something else, or change something on you. You'd want to be able to continue doing that. And again, Emacs is one of the, I think, prime examples after Linux and some other big ones where that model really shows that the perpetuity of it is something that provides real value, where you will be able to continue to use this, and the community is continuing to grow around it because of the free nature of it and certain licenses that help guide the direction of this software. And most importantly, you're invited to take part of it, right? Source code is a big part of it, and making it easy to do something with a program, to change it, is quite important. So a little bit about what is Emacs itself. It's, as you might have guessed, a text editor, but it's more a text editor environment where the way that it's written, as you can see, there's a little bit of C code, but most of it is written in Lisp, which is also the language that you use to configure and change Emacs. And the reason that, or rather the fact that there is so much Lisp in it, means that most of the stuff that you see of it can be changed to do something else. There are very, very few things that actually where you have to go down into the C code, and that's mostly related to performance. So if there's anything about your editor that you think, hey, I wish it could do this, or this could be in a different spot, typically if you Google that, you will find at least 5 different ways to actually do that. So you don't even have to learn it. You just like you do with normal day job programming. You copy whatever you find, you put that in, and suddenly your menu bar is to the left, or you have a little Sublime-like overview of your text on the right, or whatever it is that you're looking for. Emacs has been around for a while, so it says for 35 years here. I had to look that up, and that means it actually predates many of the standardizations in terminology that you may know. Words like copy and paste did not exist when Emacs was come out, so it actually has different terms for that. The terms window and frame mean somewhat different things in Emacs than in what you might know from other windowing environments, because there were no standard names for these things when they were first created there. That can be somewhat confusing when you first roll into it, but in the end, if you're familiar with domain-driven design, a bounded context is just a bounded context, and the same thing holds for reading stuff about Emacs. So, you will find stuff. And like I said, if you try and find out how do I do this in Emacs, typically the answer isn't, well, you can do it. The answer is like there are many different ways of actually doing that you hadn't even thought of. If there are any VI users here, if you're looking for how do I use modal keys in Emacs, the answer isn't really that you can't. That there are 3-4 different really big solutions on how you can get VI-like efficiency and from within Emacs. So let's have a look at Emacs first. So if you want to start Emacs and ignore anything that you may have configured before, you can type Emacs -q. So let's try and run that right now. So this is what you will see when it's a lot of light suddenly. Sorry about that. So this is what Emacs look like if you started, which is sort of kind of nice. The cursor is on the tutorial, and you can probably go in here and then start reading stuff. And actually never read the tutorial, but it's also a little boring and it doesn't look so fancy. So if that's not really your thing, there are other ways of getting started with Emacs. There are a couple of distributions, you could say, that take Emacs and add a lot of extra things on top to make it a bit more modern, add a couple more features, and make it more integrated, some other documentation on top. So if you're looking into trying out some of this, I do recommend checking out Spacemacs or Doom Emacs, both of which try and give you more than the default program you get when you just find Emacs. I also put a link to my own Emacs configuration, which will make it look somewhat like you see here. And that kind of leads to the point here that there actually isn't really an editor called Emacs. If you meet somebody that uses Emacs, then their way of using it, even the keyboard shortcuts that they use, are going to be different from everybody else that uses it. And that's not a disadvantage. That means just that the way that they've shaped this software is the way that works best for them. And they will be most efficient, because if they run into something, this is the 15th time I have to look up this long command, they will have made a shortcut for that. So I decided to sort of pick a few features in Emacs that typically you would think, okay, how do I do this if you come from an IDE background or from other editors? And one of these is the concept of the language server protocol. So LSP is something that Microsoft started when they wrote Visual Studio Code as a way to allow different languages to be supported by their editor without them writing lots of code for that. It's a REST protocol where you have some server running on your computer typically that knows about Java or JavaScript or any of the big list of languages that you see here. And the editor just simply asks the server, hey, if the user presses tab after this short word here in that file, what completions can I offer to them? And then the server responds with, oh, I know what that is. That's Java, and you could write public here or publication or whatever else that you may have in scope. So the server knows about completions, but it also knows about refactoring and renaming and navigating in code and all the things that you need to have an active knowledge of your language about. And this has created a nice little revolution, I would say, in text editors in general, because it quickly showed that the specification was actually pretty nice, and on both sides, people started writing both language servers but also clients that had nothing to do with Visual Studio Code. So now these days, any of these languages which happen to be on the LSP mode list for Emacs, these language servers have nothing to do with Emacs. Just as the Emacs LSP client has nothing to do with Visual Studio Code. You have LSP clients for VI, several, I think. You have LSP clients for Sublime Text, if I'm not mistaken. And a lot of the other editors get this functionality. And I think this is very bad news for companies like IntelliJ, because now you can get state-of-the-art Java, Scala, and whatever support to any editor without needing the IDE part, and you can just pick whatever editor works best for you. Who of you have used something like this before, like Visual Studio Code or some editors that? Okay, not so many. So I've prepared some small examples here. So Zio is a huge Scala project that implements functional. What's this? Oh, this. That implements some functional things for Scala. You can see if I just walk around this this code, I can navigate to different parts of the code base. I would be able to look at documentation and other things, and that's because there's a language server underneath that knows all about this entire tree of Scala code and has parsed it for me. But there are other language servers. There's a C++ language server. Here's some C++ code that's running some embedded stuff back at home, and you could just walk around stuff here as well. Again, there's a language server here that knows C++ and has parsed this tree. I'm not sure if any of you have written C++, but it is ridiculously hard to make sense of for an IDE because of all the defines, and we went a little bit into that in the Go talk before, where anything can mean anything depending on how you included it and from where and what color and things like that. So having a language server here that actually makes sense of this is really nice. And you know, there's language servers for anything. Maven projects you can just import. Let's look at something else. So Literate is the directory editor, which is the way that you would view files or would view directories in Emacs. What you can do is, if you're on a file, if you haven't figured out yet, we are in Emacs right now. So if I press controlx, Ctrl-J, you will see. Can everybody read this? I make it a little bit bigger. This looks like an ls directory you would get if you go to a shell and write ls, but it's actually an Emacs buffer, so I can just go to a file and press enter, and it will open that file up. Or I can go into a different directory. So the way to navigate files is fairly straightforward that way. Let's go back to our presentation here. But since that buffer is text and Emacs is text, we could edit this buffer. So Ctrl-X, Ctrl-Q is the way in Literate to make this editable. So I could say here, this actually shouldn't be licensed. It should be license.txt. And maybe I don't need my gitignore file anymore. Oh, you can't delete it. OK. But you can go in and make changes. Or I could say, well, let's do a search replace. And actually, I want all the txt files to actually be called .markdown. Oh, there's just one, and I just typed it. But you can see that thinking of this as a text buffer allows you to do file-based operations just by reusing the knowledge that you have of editing text. And well, that's something that really stuck with me by thinking, OK, hey, if I can represent something as text, I can use normal text operations to do stupid things to files that normally require me Googling for 5 minutes. How do I write a bash script that renames files or appends an extension or whatever it is that you need to be cleaning up? Another a very often added part to Emacs is called magit, which is the JIT interface, or one of the JIT interfaces that you can use with Emacs. That makes any workflow where you use JIT so much more accessible than it would be if you just used the command line. And the reason for it is, again, the customization. How you like to work with JIT, you can make Emacs do that and work with it. So if we it is, I will pronounce it Git for now. let's say that we've actually changed this file. If I go into, so should I say magit or magit now? Okay. Well, if I go in, you could see here that what head we're on, what basis we're on, but the changes that we see here, you can see this is the stuff that we that I've been adding since the last change. I can press S to stage something, just like you would say git add a file. That's just the letter S. In order to unstage it, I press U again. Now it's no longer changed. But since I'm in my editor, I can actually say, okay, I want to only stage this part. And that's already something that is extremely complicated to do from the git command line, and most IDEs don't really bother helping you out there as well. But it's so important. Maybe you want to stage something, you figured out there's this print line actually doesn't want. You could just go in and remove that little line from your stage. So now I've created a stage with just that line, and the other lines are still in there. And everything from committing and even creating pull requests and adding code reviews you can do directly from your editor. I've not played around with the code review thing right now because I'm not using GitHub for my current project. But that allows you to actually just start typing right in this editor and look at somebody else's code. And while you're running it, or while you just ran the unit test, you can go in and add comments and saying, hey, this one doesn't work on my computer, or whatever it is that you want to communicate. And that, again, it's all these small things, all these context switches that can help you be much more efficient in your work if you can prevent them. Then there's the somewhat unluckily named feature called tramp, which stands for Transparent Remote Access Multiple Protocols, which I had to look up. I had no idea. And the thing is that at some point someone in the Emacs development team had a good idea, and they thought, hey, if I have a shell access to somewhere, like an SSH access or a Docker shell or something, I can actually do a lot of things, right? You can usually do ls to get a list of things. Usually there is some sort of Perl or something else that allows you to do a bit of file mangling. Usually you have a gzip command or something to do some compression. What if we write something that abstracts the idea of files themselves over a shell and just show that in Emacs as if they're local? That is what tramp is. It allows you to, within Emacs, open anything that is shell-like. So that means doing sudo locally, running into SSH servers, SSHing into one server and then into a different server if you have a Bastion host, that kind of stuff. But also a Docker container or something running on Kubernetes, as long as if you have shell access, you can pull it into Emacs and treat those files as if they are local. So what we can try right now is, so controlx, controlf is just opening a file. You can see down in the screen what we're trying to open. So if I say SSH : here, we are trying to open a file through an SSH shell. You can see some completion of other servers that I've worked with, but we'll take JPad for now, which is the name of this local machine. I just press tab to complete that. You can see it has just made an SSH connection to my local machine, and the completion is actually already showing what's in my home directory here. So if we, I don't know, go into maybe my bash RC. You see now I've opened the bash RC of my local machine, but going back over SSH. As you can imagine, this could have been something on any remote server or yeah. And I actually use this from time to time with Kubernetes because my current client runs a lot of stuff in Kubernetes, and once in a while you have to sort of check configuration files, like did these arrive correctly? And just with one command, especially you can make a bookmark or anything you've opened, right, so you don't need to type and complete it every time. I can immediately check, is this configuration file correct? Or I could even change it if I wanted to directly by having it open in Emacs. And there are some other things that I won't go into right now, but one thing you find in Emacs that some operating systems are getting a standard, but your clipboard is not just one thing. It has a history of things that you've used before, and all parts of Emacs are aware of that. So pasting something is not just pasting. You can paste something by prefix matching this with completion. You can grab something and change it around. You can change the order of things. You can append to stuff that's already on the clipboard, and most of that works naturally without you needing to really rely on that. But you can go further than that. If you already have learned yourself a way to write text, why learn that again if you have a different program like writing mail? You can do in Emacs as well. And finally, there's this site called YouTube, if you've heard of it, where you can subscribe to channels, which is nice. But then you see other stuff as well that I don't need, and you see advertisements that I don't really need either. But all these channels have RSS feeds. So in Emacs, you can pull RSS feeds into Emacs. So if you just pull the RSS feeds from YouTube, you see sort of all the YouTube stuff that I'm interested in, and then you can sort of say, well, let's watch this video that is now getting streamed from my phone. So I have no idea if that's going to be. Well, there you go. And there's no need to visit any website or anything. I can just refresh this overview and see if there's new videos I might be interested in. And there's again, no need to lose time over things that don't really matter. And that brings us to the part that we're going to focus more on today, which is a part of Emacs called org mode. Mode, by the way, is just the name for what part of Emacs is activated for a particular file you're working on, or buffer, as Emacs called it. And the org part stands for organizational or organized, because org mode basically defines a structured way to write text files. An org file is just a plain text file. It has some of the similar goals that you might know from Markdown, even though that came a little later than org mode. Since any .org file you can just send to somebody else and it will pretty much look like a normal text file. GitHub knows about org, by the way, so if you write an org file on GitHub, it will be formatted sort of nicely, similarly to as you see it here in my customized view. So that allows you to also mix text and code blocks, like Markdown also does. The difference being that these code blocks, if you actually open the org file in Emacs, mean something. I should have gotten some water. They mean something special, in that you can actually run them, and we'll go into that in a moment. And running them is the part of org that's called org-babel, which through a plugin system allows parts of Emacs to look, hey, this piece is a bit of Python. So I know Python. I know that if I want to run this, I need to start up a Python environment and shove that code into it. Then something will roll out, and I'll put that in a results block underneath. And not just Python. Just like the huge list of languages you saw before for LSP, there is a huge list of languages that can do stuff like that, like Java, like shell scripts, like normal files, like REST requests, like SQL statements. All of these things you can directly write in Emacs and run as part of an org mode file. I have no idea what I meant with this part, so let's keep going. So imagine that we are writing a developer guide for a service that we want to collaborate on with other developers, and in order to run that service, we require some dependencies underneath. For example, a web server. So we could say that we need a dockercompose file to build that web server. Now, as you know, we are in Emacs here, and this is actually an org file. You can write some shenanigans here that demarcates a code block as being YAML. But there's this word tangle here that you can see, and there's a file name after that. And that actually means that we've instructed org mode that, okay, we'd like this to land in a file called dockercompose.yaml if we actually run this or tangle this. The shortcut for that is Ctrl-C, Ctrl-VT. Actually, before I do that, let's show you that. That's not this I want here. Let's show you that this directory right now just has my org file, a couple PDFs, and no dockercompose file, just to show you that we are starting from scratch. So if I now tangle this block, you see in the status line below, tangled one code block. If we now go back and refresh this, you see we have a new file here, dockercompose.yaml, which surprisingly has the exact content that we had here. Obviously, you can automate this in ways that you that you would prefer if you don't want to do this manually. But while walking through something, maybe that's exactly what you want. You want to show, hey, if you have a compose file here, this is the result that you get. That is typically how I do it when I present a course or instruct stuff. Then you can walk people through the various steps, and you don't need to change context because everything is right here on your slide. So now we have a file. Who of you knows how you start a dockercompose file? You say dockercompose -d, right? So let's have another piece of org mode stuff here, which is a shell script, sh, which consists of 2 commands, dockercompose up -d, and then we do docker ps just to show what's actually running. With Ctrl-C, we can actually run this shell script and show the output below, and lo and behold, we have a web server that is now running from our dockercompose file. Now that we have a web server, let's go a step further and say, well, we're now no longer writing documentation for our service, we're writing documentation for the REST API that our service is offering. Now, obviously, you would have some open API specification or something as well, but it's nice to have a piece of text where you say, dear developer, welcome to our service. If you want to play around, please try these requests, and here's some example responses, blah, blah, blah. It's nice to have something you can hand them to get started, which, again, you can do directly in line here. Now, the first thing is that we have a web server, but in order to simulate that we have actually built an API, let's give it something to serve up. So let's make an XML file here that we're going to call test.xml. Well, we know we can tangle that out with Ctrl-C-V-T. Now we have a file called test.xml in the directory here. There you go, that has arrived. And so now we should be able, because if you look back here, we've bound our web server to port 8080. We should be able to send a GET request to 8080. Now, I'm not going to go to a shell and do curl. No. There's a thing called restclient in Emacs where you can directly make a REST request. Right now we have a request with no headers, but if you wanted to, oh, there's actually an example here I put. So let's just start with making the GET request and see what actually happens if we execute that. And you can see we got some XML back. Somehow Emacs figured out that this is actually XML, so you get the highlighting as well. And then since it knows it's XML, it actually puts some metadata in XML comments, so it still is a valid XML block, but this obviously is stuff that came from the web server. So that's pretty nice, but get is not the only HTTP method, so let's try and put something as well. Hopefully Nginx will prevent me from writing to that directory. Yeah, so it didn't like that at all, but we still get a response back, in this case HTML, because probably the content type header said that. There you go, text HTML. So that's pretty nice. You can demo this, but this is just as text, right? This is still just org mode, and you may want to actually send this to others and collaborate. So you can make presentations with this, but since org mode inside Emacs can be converted to other formats, you can actually export a PDF here. And if we open it from here, the plain Emacs feature to export PDFs will give you something that looks like this. Is it the O there? Yeah. So you get the sort of, if you recognize the font here, there's a well-known program called Tech that is being used underneath. But it looks like a nicely formatted thing where your headings turn into numbered headings in your slides, basically. The text goes into text in the document. Your syntax highlighting still works. It looks pretty much like a readable, nice document where all the things that you wrote in org still are there and are represented there. Again, there are certain layout things that you may want to tweak a little bit, like how long the lines are and other things. But if PDF is your output, that will work fine. Obviously, you can make HTML, and God knows what, you could even turn it into Markdown or a Word document if you really wanted to. There's the whole bunch of things that you can turn this into. But there's this other package for tech called Beamer that actually allows you to make a PDF with slides, like normal boring slides, actual fixed text. I have no idea why you would want to do that, but you can. because that's just a matter of reinterpreting this org mode document in a different. Did I just open the same one? Just happened. No, we want this. Yes. So that just reinterprets the same org mode document, but in a different way. Now your headings turn into slides, and subheadings turn into subslides, and now we have the same text, the same content, but now we can sort of go one page at a time, because you may want to have that as a fallback or send this out as handouts or something that sort of resembles what you were doing, but other people can use directly as well. Yeah, there's some limitations to the Beamer part though. So you basically have to mix and match a little bit on what you most want to get out of it. So like I said, I've used this for a couple of things I did for Lund&Bendsen, and I could walk you through 2 examples here that might show a little bit something more close to home to those that have used Java, where if we just focus on this one just to make this a little bigger here. So here I have a code block that is indicated as being named Java. And I do have to tell org mode that the class that we're making here is called type inferred, because it's not smart enough to figure out that there's just the one class. But there's some Java code here with a main function that shows, for people that don't know, what the var keyword does, and there's some functions there as well. This is not a Java course, so I'm not going to explain that. There we go. But the result is 12, obviously. But if we hack around here and we're doing some calculations here, so if if I make this 6 and I run this again, then we get 22. What is this trying to do? We're doing something twice, and then we plus. So we apply the plus 2 times, and then we. Okay. I wrote this code, but I already can't remember. But the thing is, you can play around with this while you're doing your presentation. If you get a question, hey, how do I, what happens if I do the twice? Okay, then let's, why can't I select this the right way? Apparently that doesn't work. If I run this function twice on this, then, well, it changes to 43 because now it does the calculation 2 times. So interaction becomes a lot quicker when you have the rest of your slides still available. But as you saw, this Java block that's built into org mode, by the way, it allows you just to have the one Java class, and it uses the Java compiler directly underneath. And that means you have no libraries. There's no akka, no VAVR, no Spring, no nothing. Which is okay for, examples like this. But if you actually have a course where you go deep into God knows what, then you want some examples that have a bit more context. And to this, I've been working a little bit on trying to get something called JShell integrated into org mode. As you can see, there's a block here just called JShell. And that does not exist in normal Emacs. I've been writing that on and off for the courses that I've been giving here, but I'm still not happy with the quality and the predictiveness of it. But what you can do is you can write a block, and if I run this, it should be starting some JShell underneath, and we don't get anything out here. But if we now run this block, you see now we get some output here. So who of you knows JShell? Well, it was actually new for me up to like a year ago. But JShell is a shell for Java. It's a REPL, a read, evaluate loop that allows you to start a Java environment, and then you can just type stuff and then get a result, and type more stuff and get another result. And it's pretty nice because there's actually a Maven plugin that allows you to run a JShell on your Maven project with all the dependencies and your code present. And that's what actually this is doing underneath. So when it sees a JShell block, it starts a process with Maven running JShell. And then the stuff that you write in your block gets sent to that process, and then what comes back gets digested into potentially a result here, like the 1, 2, 3 that you see. And that allows you to actually use all the libraries and other things that you may have underneath. When I get more time, I want to make this a little smarter because for this I'd have to show it in actual shell. So if we try and run JShell here, it's pretty nice if you use it from the console. Since if I start to create a I don't know, my function, you can see if I press the closing parenthesis, it sort of jumps to the left and then jump back. That's all communication that gets sent to the console. So imagine that you are not you writing this, but you have to write some code that talks to this and then gets stuff back. It's a total disaster. If you have a new line in there, you get this extra arrow on the left, which is pretty nice if you're writing code. Not very nice if you're trying to read the response and trying to make sense of, am I done here? Was this a compile error? So if I make a compile error here, then at some point it gives you some feedback that it didn't like what I was writing. But this was not meant to be automated, and I'm still on the fence whether I wanna push this further or just take the losses and limit what we do here. But I think it's good enough for instruction-like things where you just want to have some quick code examples, like this is how you create a reactive stream in this library, or this is how you talk to RabbitMQ, where you can go in and change that and show people what it's doing immediately. So that is shown to be quite valuable. So I have some stuff here on how to actually set some of this stuff up in Emacs, but I think we can postpone that for now. I just want to ask, are there some questions, like how do you feel about seeing this? Is this something that you've seen before? Do you know alternatives? Do you have suggestions on how you would spin this? Does anyone have any thoughts? Like what tools do you use when you need to? Yeah.
My first thought is this goes a little bit against the Unix idea that you have many small tools that are good at one particular thing. The idea that you have one tool to rule them all. I know this is not a tool, but it's a bit against what I like, to be honest.
Mm-hmm. Okay.
But this is actually not one tool. It's actually an operating system where you can download small tools and make them work together. So this is exactly what you want.
So discussion is a little bit about, should we rather have many small tools that solve one particular purpose? In a way, I do agree that makes sense. But what you haven't seen is that under the hood, these small tools are still there. Restclient doesn't sort of re-implement HTTP protocol and other things itself. I think it actually calls curl or something underneath. All this does is allow you to solve the specific issue of, hey, I want to have text and dynamic blocks in one. And you're gonna have to be in the realm of text editors to solve that particular.
So let's just take, for example, you have that REST client.
Yeah.
And the REST client has to make a call to an HTTP that use an insecure certificate. So you need to add a ---- insecure to the REST call. How do you do that?
So the question is, your REST client needs to make an insecure call because it's a certificate that it doesn't trust. I would say I wouldn't, for a variety of reasons. But if we generalize, like, what if you need to customize the curl thing underneath? You would go in and wherever that is defined. I wouldn't be able to tell you off the top of my head, and put those extra options in, right? Maybe there are some parse options to curl that you need to have. I would guess that in org mode they would typically land on this line here where you start the code block, so they would be very much still visible And if anybody speaks curl, they would recognize that, okay, these are extra options that go there. So your Unix knowledge, I think you can still very much reuse. Similarly, for the JShell stuff that I'm writing, what you don't see in this presentation stuff, you just see JShell. But there's a huge list of Java imports that get automatically imported to, for all the libraries that are being used here, and that is sort of silently stepped over because it's not so interesting and not that important. But it's there, and it actually needs to be somewhat visible. And yeah, these are things that come up, but they come up in any Maven-based project as well. You probably put that down into your build file somewhere, and well, these are it's probably where I would put them in a more final approach, and then it's still somewhat reusable, right? And the JShell plugin for Maven would reuse that as well.
Well, I think isn't it okay that we need an integration so it's still JShell is still a Java tool that just you have to make some integration package to, and of course if that becomes too big, then it can become awkward. But I think it's fair enough. I have another question actually. My daughter goes on the university, and they use something they call Latex, and that produces extremely awesome, beautiful documents. That was what he was just using.
Yeah. So well, we didn't come to the question yet, but the remark was that somebody's using Latex to make beautiful documents. That's what you just saw. So if we go back here. If you go back to our presentation, you see that in our, well, this is actually the wrong folder. Let me go back to the actual presentation, which is here. Yes, and there. So I didn't actually export it. So if we try and go out of my presentation mode, and then we say, what was it, country export, and then we say export to Latex, as you can see on the right-hand side. Yeah, and then we we'll make a normal PDF, please. Working, thinking, done. Now, if we look at all the stuff we've gotten, we got a new file. What did we? There you go. So we got an actual normal, well, I don't know, if you speak Latex, this is pretty normal file with, what you just saw in org mode, but now in Latex flavor. That will, through a variety of instructions, will be fed into the PDF version of Latex, and that will actually create the PDF file. And there's actually a myriad of ways that, just like the curl example we just talked about, where you can influence, hey, if this ever goes to Latex, I want you to use this table format or specific things.
Oh, that's cool.
Yeah, I think so. So the question is, if I use this for teaching, do I expect the students to use Emacs? And no, I don't. I've used it both at Lund&Bendsen and outside, and it is really enough to give them a PDF version so they can look at the rendered stuff offline, sometimes two, like the slide one and the handouts, and then the plain text document, typically on GitHub, where it also gets formatted into nice HTML. And that's enough, because it's, from the student's point of view, it's consume only. They typically don't send pull requests for the slides and say this needs to change. And even if they did, it's a plain text file. So I think many of the textual changes could lift on the normal GitHub pull request flow as well.
Is it your experience that the course gets more focused? So when having these snippets that focus only on the code that is getting written, or is getting executed. So for instance, you don't have the imports and all these things. So usually you can get questions like, oh, why do you have this? And why do you have this? And you have to say, don't worry about it. So this element has basically been cut away because you're only focusing on what is important.
The question is, does the course get more focused by allowing you to have just these snippets? And I would say the answer is yes, but intentionally so, and in a particular context. So if you imagine a course where you are teaching a framework like Spring, you could be showing some Spring-specific code. And I would typically introduce that fairly early on to say, well, this is what it looks like if you wire up a bean or do some configuration. And you're writing not any code yet. But it does need to come together with like an example project or something where there is the full code set. And I'd say both are needed for students to actually run. But yeah, the focus is very much there on the slides, and it takes a lot of the technical context switching out when you're instructing, where you just have this one thing and you don't leave it, you don't switch windows and fonts and different environments and stuff shifting in everywhere. It's just, no, this is the code and we can change it a little bit and then we just continue with the next subject. So it makes for a very quiet experience when it works.
And can you use graphical output like WAV files or something like that?
The question is, can you use graphical output? And the answer is yes. Let me see if I can find an example somewhere. Because I just drew something, but I'm not sure if I can show it. Let me just answer it directly. I think I have one in. Yeah, the Java. There was a thing with the God, where. So while I find this, so yes, there's. If you know, there's a tool called plant-UML, one of the Unix toolbox things that takes a text file and turns that into graphics. That very much is a something that you can integrate into org mode, and is actually there by default. And I actually showed, now I just remembered where that part is, but I'll show the graphics thing first, which is this here. No, that wasn't here. No, I think it was actually in this guy, where. So yeah, so if we go here, there. So you gotta have a graphics, and there's a. Did I miss what this showed? So you can have an animated GIF and do some other stuff, and so that's more rudimentary things, and that will sort of just allow you to have a bit more fun in your slides if you think this is fun. The other example that was on my Scala presentation. So if we where did this go?
Talking about something like a database
yeah.
layout or something like that.
That is how did that disappear?
But you would be able to import any image, right?
Yeah. All images would work. I just really want to show you the. Oh right, I think it's. Yes, there we go. That's where I put that. This is another talk I had on Zio, which is that Scala framework I talked about before, where there is a little image somewhere here. Where you can see this is plant-UML. In this case, it makes a sequence diagram, I think. And if I run this, then you can see the actual sequence diagram that's rendered underneath. So you sort of maintain this as text in your org file, and when you present it, it actually becomes, and export it, it becomes an actual picture. And again, you don't have to learn anything new. Plant-UML is extremely well established and does, well, UML-like things, actually does more than just that. So there's no need to be afraid. Yeah.
It would also seem that you have, it makes it really simple to fix and improve the presentation as you're giving the talk, instead of you come up with there's a great idea, oh, I should really explain that, and you type something and it's there right away, instead of sitting in PowerPoint and go into edit mode and write or correct a typo or add another line, because it doesn't have the context switch to editing either. It doesn't have the context switch for the consumer, for the student switching to the code, but it doesn't have the context switch to editing if you decide on the fly to improve on your material.
So the remark is this makes it easier to extend and improve your slides on the fly. And yes, that's very much a big part of this. If we're talking about this picture, and we suddenly see, oh, there is actually a bullet missing, then you say there should be a bullet here. And you can't only just type this and people will see that you've acknowledged their thoughts. You can later go into your JIT thing. This is actually not on a version control, so it doesn't work here. But you could go into JIT and then see, hey, I've actually written this today, because you've obviously made a commit right before you started it, and you can see, oh, these are my notes, and then you can clean it up and put other stuff in there.
So in principle, you create a branch every time you started it, so you have a branch for that presentation for that customer.
Yeah, I think you can do a branching strategy how you would like. I'm not quite at the level where that has gotten completely out there, but yes, I can imagine that making sense. Yeah. I mean, these are text files, right? So, and JIT is really good at diffing that. And if you stick to stuff like planned UML for your text and REST client for your REST requests, and it's all just text in the same document, and diffing that is a solved problem. Well, yeah.
I'm just afraid if I was about to do that I would become sloppy in preparing my slides, because it's all, dynamic, live. I can fix it later, instead of, preparing my slides properly before needing them.
So the remark is that one might be afraid that you get sloppy because you think, oh, I can fix this while the slide is there, instead of preparing everything ahead of time. I would say in my experience, the reverse is actually true. I have given presentations with, I don't think I've ever used PowerPoint, but with Google Slides and stuff like that. And I would say 9 out of 10, the code that I paste on there is wrong, because there's a parenthesis missing, or I missed a semicolon that Java still has, or God knows. It's never quite correct. It's also not a big deal, but it's not neat. But in this case, if you put the code in there, you're going to have to execute that block at least once. So it means if you don't come back to it, it will still be correct. And additionally, I have a small remark about that. At the end, you can imagine a unit test of sorts that takes your whole presentation, executes all the code blocks, and makes sure that they still add up to whatever it is that you want to come out. Remember, with JShell, you have some context, right? You first do this, then you do this, then you introduce this variable, then you run this stream, and then you get 42 out as a result. If you run that again, you hopefully get the same result. So if you run that and your JIT doesn't tell you that there are any changes, then all the code is still correct. So in that way, you can unit test your slides. So I'd say there's actually more options to not needing to be sloppy, and actually have a bit more confidence about what you're having out. Or but hey, if I upgrade to this new version of Spring, is my code still correct on my slides? Well, I just upgrade it in Maven, what you normally do, and execute it again and see if it works.
Yeah, just to comment on that, you can also put it on Jenkins.
You could put it on Jenkins. Yes, I suppose you could. Like I haven't tried any of these things yet because of the frequency I do these things is not that big. But yes, any kind of automated testing. I'm pretty sure you could make Emacs run in a Docker container and do its thing, for sure. There's one final message. So if you're thinking, oh, this looks really interesting, but I'm never going to learn all that. I've been a couple of years in learning Emacs, and no, you don't start with this, but you start with having a feeling that, my head is exploding from having all these different tools that all serve one purpose that have to do with text editing. Like different shortcuts, different ways of doing this. What if I could use something where at least I can reuse my knowledge and it doesn't disappear? Try one thing at a time. I actually didn't start using Emacs for coding at all. I started using it for writing text, and not even org mode either, just markdown files and things like that. I think at the time I didn't have a good markdown plugin for Eclipse, so I had to use something else. I figured may as well start with Emacs. And then you sort of take one extra thing, take one extra thing, takes one extra thing, and see if you can make it fit.
Is there anything left of an IDE when you use this editor?
The question is there anything left of an IDE if you use this editor? Well, the IDE-related features that I tended to use in Eclipse or IntelliJ, like navigate and highlighting and plugins, they're taken care of by this. But only because, don't tell anyone, if you use the Java integration, there's a headless Eclipse running underneath. That's what it talks to. That is the language server for Java. It's just Eclipse. It's just you don't see it. The Scala one has a thing called Metals, which is developed by the Scala team themselves. And, well, they all sort of have their different ways, but that is your integrated development environment. LSP also has ways of debugging that I've never used, and millions of other bells and whistles that I'm sure are very interesting IDE-wise, but I actually haven't looked into as well. So yes, your Emacs environment is your integrated development environment in that context.
you in some way reference into that, so you don't replicate your code, but rather reference like snippets in files.
Like on the slides themselves?
Yeah.
Okay. So the question is, can you refer to part of an existing file in your slide? And yes and no. I know there are a couple attempts to try and pull in stuff from files rather than export it. I've not looked into that. I know the reverse is more, how do you say, you find it more often, that you have a block, you turn that into a file, and what you can do is actually activate your language server on that block in org mode. So you can actually get completion and compile errors live while you're on your slide. But that requires some more tighter integration that I've not set up. I didn't quite find it worthwhile, but you could do that. But it triggered one other thing that I just want to show as a little demo. So if we go back to our big file here, I suppose you've all seen big code bases before, right? What I always found the most annoying thing ever is that if you have your code base and of course they don't have a format or something else, so you have this line that goes on and for 160 characters, and you find yourself scrolling. In Emacs, if I make this bigger and bigger, there's still no horizontal scroll bar because it can just word wrap this Java code and keep the indentation as you would. It's Scala, but you have no idea what this means, but it doesn't matter. You can see, okay, this line just goes on. You have these little markers on the left and the right. So you can keep reading this as code. The same with the documentation. You see these extra stars here. If you look with the half eye, you don't even recognize that there's some line being wrapped here. And that's just all taken care of for you. So browsing through source code, especially that you didn't write yourself, I've not seen this in another editor. This is just a small feature that maybe IntelliJ or Eclipse can actually do this, but I've never seen it. And it saves so much time if you run into a code base. Or you have a presentation, you need to zoom in and say, oh, there's this blind person in the back with no hair. He can't read this. So you just keep making it bigger and it will word wrap. This, sorry, that's a... yeah.
That's really
There was,
cool when you get older, right?
yeah.
Like
I mean, I can fight it myself. I need to keep it bigger and bigger and bigger. I have these like 4,000 pixels on my screen that I never use. It's
these language servers, you said that there is a language server for each language. That's correct, right? So
well, I wouldn't say there's a language server for each language in the world. I'm pretty sure there's none for Danish, because who would?
sorry, that's the question was phrased wrong. So it's not one language server that serves all your languages when you work.
So the way the language server thing works, so the question is how many language servers are there? And I think they work on something called a workspace or project thing, where typically your Git repository or one project where your Maven file or your SBT build file or something pulls stuff together, that gets handled by one language server. And then sometimes also multiple of these projects get handled by one instance of the language server. I think it depends a little bit on which one you're talking with. But it's per project, it's not per file. So there's one gigantic Java Eclipse process running that handles sort of all the Java stuff that goes on in my Emacs. And then there's a different process that handles all the Scala stuff. But I think there's actually one per project. And then for the C++ ones, there's also one server per C++ project and all the include files and source files that you have there. And all these processes are handled by Emacs, so they're spawned as sub-processes. Another point there, my pre-Emacs experience is mostly with Eclipse, but I've had more than once that Eclipse is doing what Eclipse does best and garbage collecting, and God knows when you sit there you can't even type because it's scanning your source files and rebuilding and everything else. It still does that with Emacs, but in a different process. So it can never kill your editor. You can keep writing while your IDE figures out what it wants to mark red today, but at least you can keep writing code. And that, to me, that distinction is also a very, very big win.
What about, is the language server running locally on your machine, or is that somewhere in the cloud?
The question is the language server running locally or in the cloud? It's running locally. And it's also automatically downloaded and configured by Emacs. And the other editors that use LSP work in a similar way, where it will pull in Eclipse or whatever it is that you need automatically and run this locally. If you use tramp, so if you are editing source files on a remote system, if you've installed this language server there, then all this stuff will still work, also remotely. Okay,
So,
I think that brings us to the end. Yeah,
excellent. Thank you so much.
thank you guys.